Hey guys, my name is Jason. We are back at the mine today and we are going to do some hardcore geologizing on this thing. I'm here with Dale from Tamarack Geological Services and we're going to do a bunch of geology stuff today. We're going to do some strikes and dips, we're going to do some foliation stuff, we're going to talk about vein emplacement, we're going to talk about rocks, we're going to talk about all kinds of cool stuff. So I can't wait to get started on this thing. It's getting to be right at the end of the season here. I don't know if you can see behind me, there's snow just right back up here. We had to fight snow coming in, we had to fight rain coming in, bad roads, long drive, but we made it to the mine one more time this season. All right, Dale, so we are here back at the mine. Kind of our goal today is to take a bunch of measurements, get them back into the office here in a couple days, put them in Leapfrog, which is a program you have.
Yep.
Tell us kind of your goals for today, what you're looking to do, and what all this is going to tell us at the end, hopefully.
Yeah, so one of the goals today is to get the data we need in order to geo-ref in some of Jason's maps into Leapfrog. And so that way we can build him a little 3D model of the underground workings, which could help him understand where he's at as he's headed towards that fault race.
Yeah.
So that's one of the main goals. Part of that process is going to be GPSing in the portal over here and also where the vein outcrops at surface. So we have those known points that are at surface and on his maps. So we should be able to use that information to locate that map in 3D space and then draw some lines and make some shapes, and it should be easy to spin that model around in 3D and see roughly where you're at.
Yeah, no, that's gonna be awesome. And what that'll do for me as a miner, we're gonna talk about a lot of cool geology stuff today, but just from a mining standpoint, it's gonna tell me where I am in 3D space, where I need to go, and then we can also start talking about reserves. We can extend the vein in space a little bit, see what, where maybe I can start mining in the future. I can set up some mining plans with this map, so I'm really excited.
Yeah.
I'm super excited.
Yeah, it should be pretty useful. So while we're up here today, we're probably gonna throw that data in our laptop and just check everything while we're in the field, because we don't have many days left.
Yeah.
So we wanna try to get everything we can before we're not able to get here anymore because of all the snow. So it should be a good day. Excited to run around in another Gaber goose chase.
Yeah, right. It'll be a fun day. And for all you viewers, this is what Dale does. I mean, he has his business, Tamarack Geological Services. This is what they do. So if you got a project like this, I'm going to show you today what he does. And but this is definitely something that if you're looking for these services, give him a call.
Check us out, tamarackgeo.com.
So we all know this place. This is the blacksmith shop, the portal to our mine. Our track goes back into the raise there. And one of the first points we're going to get is a GPS point of the portal of the blacksmith shop. And that way we'll have a reference to where this is on our maps in the future.
So I'll call this Blacksmith West. And then we'll hit that one too.
Okay. This will be blacksmith north.
North.
And then that one will be south.
Copy that.
And then the vein outcrops actually right to the south of that.
Okay, cool.
So I'm going to give a quick little talk about the rocks we have here. There's 2 or 3 main rock types we're going to talk about. This is Darrington phyllite. This is what hosts the vein. So all the wall rock, all the waste in my mine is this Darrington phyllite. And we'll get into a little bit more detail on that in a minute. But that's to the west. So we're going to talk about this line being a contact of the Darrington phyllite here on the west, and to the east, pretty much right here at the portal. I'll show you down here in just a second. But from here all the way across the valley, up in those snow-covered mountains all over there, is all volcanics. It's all, there's some intrusive stuff, there's some tuffs, there's some volcanic stuff over there. And it's no coincidence that these veins intruded into the phyllite right near the contact of the phyllite on the west and the intrusives on the east. So the water is really flowing out of the mine today. It's been really wet up here the last week, but this is an example of that intrusive. It's a little bit hard to see. It's really weathered and cracked up, but it's a little bit, I think they call it a quartz diorite on the maps. But it's this volcanic intrusive. It came up and cooled under the ground as a pluton, And this probably is the mechanism for heating up the surrounding area and emplacing these veins that are full of gold. All right, so Dale's got an app he likes.
Yeah, so
for
I
some
used
of these projects.
So I used to use this app a lot when I was working in the geotech engineering business, when I was mapping rock slopes. So this is pretty handy because we can collect lots of strike and dip data, way more than you can ever collect with a Brunton and writing it all down. And the beauty is it's all geolocated. So it uses the GPS on the phone to plot the position in real space. So when we're outside, it's great. We got a GPS signal. We can do a bunch of quick mapping of this phyllite as we're kind of working our way around, grabbing the GPS data that we need for our leapfrog model. So we can take all that data that we collect outside and we can plot it all in a stereo net. And that stereo net data helps us visualize the strikes and dips of all these different things we're going to measure in a way that makes sense to us as geologists, and can also help us understand how all these features we're going to measure relate to the big scale geology that Jason was just talking about, and also help us understand, maybe why this vein's here in the orientation that it is. So we're going to get a lot of that data today while we're out here messing around with GPS.
Awesome. And stereo nets are really cool. They're used a lot in structural geology, and it's a way to plot a whole bunch of data on one stereo net and see if they all line up. So you can say all of these planes are lining up, striking, dipping this way, and then there's a bunch of other ones that are striking this way and dipping this way, and you can compare a lot of different data points all at the same time. Really, really cool. We'll show you here a little bit later in the video. So we're outside the blacksmith shop here, and we're gonna get some data on this phyllite. What are you seeing, Dale, you like?
Yeah, so we want to get a sense for how it's sitting in space, and put our phone in the right orientation to grab the strike and dip. And not only do we want this, but we want all the joints that we can find. We think these are related to obviously opening this portal, but as we go around the mountain here to where the vein's outcropping, we want to get all the data that we possibly can, because all those different discontinuities or breaks in the rock can help us work out the bigger structural picture. So it's going to look like kind of chaos, like we're grabbing every little thing, but all that information is really helpful in working out the structural geology and looking at the stereo net. Up here it looks like it's kind of coming down like that, but if you look around the corner, which you always want to do, I see it coming down in here.
Yep.
Agree with that, Jason?
Yep, I sure do.
Cool. So then we'll come in here and we'll line up on that plane, wait for this thing to stabilize, hit the button.
Whoa, that's rad.
It's pretty cool. So then you can come in here and make some notes. We can take pictures, we can make notes. We got our lat long, which we can bring right into GIS. So I'm just gonna say, this is I'm gonna shorthand the phyllite DP.
Okay.
DP, and then this is all comma delimited. So every time you put a comma in, it'll make a new column in Excel.
Oh, nice.
So you can, add all your notes and just break them up by columns. You just gotta stay organized.
And just shorthand them, yeah.
Yeah, so we're gonna call this DP, and I'm gonna call it S1. And on my third section is just gonna be notes. So I'm just gonna call this, we call it kind of sweat quartz around here. Done. Okay.
Man, that was so much faster than the way we had to do it in class.
I know, right? It's
oh,
pretty
man.
wild. It's pretty wild. I mapped this big project in Nevada kind of the old-fashioned way.
Yeah.
It took me a couple weeks to get, enough data to make some sense of the geo. And then I came back and in 4 days got like 700 data points to try to prove up all the different concepts from the mapping.
Yeah.
With this thing.
With GeoID.
Yeah.
Man, that's cool.
It's pretty handy.
There's another spot looks good, yeah.
Yeah, this looks good. So in general, this, get up.
Yeah.
This phyllite's kind of a, Jason's talked about it, kind of a higher grade metamorphic rock. And so, what you're seeing in here is all the segmentation of the different minerals that are in this rock and also the quartz. And it tends to preferentially like to go and be in place along these cleavage planes. So we're gonna go ahead and grab one of these. We want to look around corners just to make sure. So I can see right here that this is kind of trending down, and it's, you know, pretty parallel to.
That's so cool. You just press a button, boom, it's there. Another thing is we're gonna collect probably hundreds of data points today, and with the phone it's so simple. And we're not so concerned with getting exactly every one perfect. We're looking for large scale trends. So if we're off by 2 degrees, 5 degrees, it's not that big of a deal. When we put them all in the stereo net, we're gonna see them all kind of line up in this zone. And so our goal today while we're out in the field is we're collecting data points as fast as we can. Just boom, 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 put that phone on it and get as much as we can. Dale's got 3 or 4 already in the last 2 minutes. Dale's doing some extreme rock climbing geology here.
3 points of contact, man.
3 points of contact, you're safe. But
don't look down.
Yeah, right in here is that upper vein. It's real hard to tell when it's on the surface, but you can see some white out there, I hope. And it just trends right up there. There's that little fresh face I showed you earlier. But it comes right down, kind of right through where Dale's hips and knees are, is where our upper vein is. And when we get underground, you'll see it a lot better. But we'll get some data points here and then move our way around, get some better exposure. Lots of data, lots of data.
Yeah.
And even in the fog, the view is pretty darn nice.
Yeah, not too bad up here today.
No, I thought it was going to be snowing more on us.
Pretty much parallel to the vein, right?
Yeah, or that's almost vertical, huh?
Yep.
And how far? We were, what, 150 feet away from the portal is right down there. And our foliation has just stood straight up. Here's another technique we can use if we can't actually get up to the outcrop. You can line it up with line of sight. We're looking at this structure right here and some of these other joints and stuff going that way. And Dale's just using the phone to project that line, that plane out, and get some strikes and dips that way.
Yeah, I don't know if we want to climb up there.
No, I don't want to climb up there.
It's a little slippery.
But we can still get some data off that stuff. All right, we're going to take a look at our stereo net of what we got so far before it gets a little too busy here.
So we were just measuring this kind of steep. So these lines that you're seeing are plotting a representation of that plane on a lower hemisphere. And so you can see how the lines kind of arc around, you know, from this direction. It kind of swoops down, it comes over here. That tells us is that plane's dipping that direction. And you can actually measure, based on counting up these little blocks, what the dip is.
Nice.
And so this is pretty cool because we can get a preliminary sense of what our trends are. So we've got a steep east dipping. These lines right here, dipping steep to the east. That we have measured as foliation. Then we have some that are kind of steep to the west also. And so that's a really, that's kind of indicative of these kind of compressional environments as you make these really tight folds.
Yeah.
And so what we're probably measuring here is an axial planar cleavage, potentially, that's like parallel to that tight fold.
Yeah.
So the rocks go like this, and they squeeze like this, and then during that process, all this heat and all this pressure makes all those minerals align parallel to the kind of the plane that cuts that fold in half.
Yep.
So that would be the axial planar cleavage. Could be one option here of what we're measuring. It would make sense because we have a lot of compression coming from the west.
Yep.
When we form the cascades here.
Yep.
We have a thrust fault right here that's in an orientation that would support that also. The interesting thing is that in the stope, the orientations are a little different.
A little different. But
So-
the thing that I'm noticing, we've gotten 20 points of data on both sides of the vein, and you're seeing different orientations. And a lot of times when you have these really tightly dipping folds or tightly folded rocks, if they break right through that axial plane.
Yeah.
And that's where you're going to get some of your veins forming.
Yeah. That's where we see a lot of veins in the Coeur d'Alene mining district.
Okay.
Potentially similar type of system, an orogenic system. So those veins were all formed from mountain building. And we see a lot of veins related to either the axial plane or in one of the limbs
Yeah.
of those tight folds.
Yeah.
Those folds are really important for making ore deposits because they generate a lot of heat, a lot of deformation.
Yeah. Well, that's pretty cool.
Yeah, so we're gonna it'll be really nice when we load all this data onto the computer, because then we can actually look at a big stereonet
Yeah.
and start making some better sense of it as opposed to being on a wet phone.
We really jumped the gun a little bit. We're getting all excited. Yeah, we're getting a little excited, and we're looking at our data and we're trying to interpret, which, you know, is fun. That's the fun part, especially for us. But as you go along, you're making these hypotheses on what you're seeing, and no one has ever done that for this mine. No one's ever done that anywhere in this mining district that I know of. And so we're kind of pioneering the geology here, and you come up with all these ideas, and then you gather all this data, you go back to the office, you plot it all, and then you're like, no, that doesn't work, that doesn't work. Oh, we got to check out this more. But it's really, really cool to be able to do this on a phone with Dale, I've known for 20 years, we went to school together, and we're doing like the cool stuff. This is the fun part. This is great. So as you come away from the blacksmith shop, our foliation just changed big time. Laid way over.
72 towards 210. So down to the southwest.
Yeah, okay. 72 though, still pretty steeply dipping.
Yeah. Still pretty steeply dipping.
That almost looks like vein orientation to me. Whatever you got there. 150 something?
It's 196.
Oh, okay.
But let's see, our little vein shots were over there by the blacksmith portal were like 105 and 115.
Okay.
Both direction.
Okay. So this has come around. So this is more of a joint.
Yep.
We're coming up into this first really steeply dipping north-south trending fault. It cuts the vein up here. You'll be able to see that up here once we get up in this gorge a little bit farther. But there's a mafic dike that runs right up that fault. And we're finding float here. I want to show you. So here's this mafic dike we're finding. Super fine grain. So that tells us it cooled really, really fast upon emplacement. So it shot up in there and cooled really fast. The brown on the surface is just oxidation, so it's just weathered because it's got a bunch of iron in it. But you've got these little dikes that run up most of these north-south trending faults. And that is another potential indicator for orogenic emplacement, right? Is that what we're talking about, or volcanic?
Well, what we're talking about is these north trending faults are thought to be kind of extensional, so happening around the same time that all these igneous rocks were in place, and those are all kind of related to the Cascade magmatic arc. So kind of tertiary time frame, like 30 to 80 million years ago or so. And so the big question right now is we've got interesting things in the rocks, that foliation. We got thrust faulting, which kind of suggests maybe an orogenic origin. And then we've got all these igneous rocks around here, and some studies that have been done in the past that have suggested intrusive related. So one of the things we're trying to do right now is sort out, with not only all this data, but these intrusives that are squirting into these north trending faults is how is that all related to the gold? And is the gold higher grade next to those dikes? Does it zone out away from the intrusives, like off to the west? These are all things that we're going to kind of look at. Jason's got a pretty good handle on it, but that'll all be kind of supporting data for this hypothesis that we're, you know, working with right now on how the gold's in place. And the reason it matters, because if Jason wants to go find some more gold, you know, if it's an orogenic origin, it's going to change where he's looking.
Yeah.
If it's an intrusive origin, he's going to be looking next to intrusives.
Yeah.
So that's why we care. That's why we're thinking about it. And then Jason's next gold mine that he finds.
my new gold mine.
His new gold mine. You know?
Yeah.
Maybe it'll be intrusive related. And hopefully we'll understand a little more about that today and over the next couple days.
And that's something else I've talked about on some of my past videos, is it's really, really difficult to prospect around here. I mean, you know, if you look out behind me, you can't really see much now, I guess, but it's covered in brush and talus. It's really hard to find outcrops around here in the North Cascades, and there could be a bunch of veins right up along this intrusive contact that have never been found. And so if you can narrow down where you want to look, you can go out and you can start prospecting these creeks and these areas where your chances of finding quartz veins with gold goes way up. And so right now that's what we're doing. We're trying to answer this question as well. Dale's maybe trying to answer a little bit different question than I am, but I'm trying to answer this question: where's the gold? Where do I go look for more gold? If I'm mining, which way do I mine? If I have a choice to mine towards one of these faults or away from it, or if I have a chance to mine towards the intrusives or away from it, that's what we're trying to answer here. Here's a piece of float that has a really nice fold in it right here. And this is what Dale was talking about. On a much larger scale, you'll have the same thing where if this was in place, you'd measure this arm here, whoops, and it'd be a certain strike and dip, and then you come over here and you measure this arm here and it might be a little bit different strike and dip. And we were talking earlier how the veins right at that hinge is where all the force is. And so this stuff can be folded, and finally it'll break and it'll shear right through that fold hinge. And that's why you get some vein, you can get vein emplacement right along that fold hinge. So there's a real life example on a rock of what Dale was talking about that could be happening on a much larger scale right here. So we're standing more or less right in this fault, right?
Yeah.
And what are you seeing here?
Well, I'm seeing like the main, what looks like maybe the main break for this potentially extensional fault. It's like striking north and dipping steep off to the west.
Yeah. And
the reason I think maybe that's the case is because this whole face over here, if you can kind of look up, it's a bit foggy. It's all coming in at an oblique angle to that fault, and it's like kind of a ragged face.
Yeah.
Going all the way up.
Stepping up the valley.
Yeah, but this is like much more of a slick face.
On the east side, over here. Yep.
You see that from there?
Yep.
Yeah. So I'm gonna, when I measure these faces as we go up, I'm just gonna call them fault ? Just so we get them in there and we can filter them out and we can plot those separately, and then we'll get these foliations that are coming in on this right hand rib or this right hand wall as they're coming in, and that'll give us a really good sense of how the rocks are changing on this side of the fault versus on this side of the fault, and then we'll be able to project this right down into your stope pretty much, or at least the fault rays.
Yeah.
This fault rays comes right up through here.
The fault rays comes right up underneath that big rock right there.
And it's coming up from the east, right?
It's coming up actually from the west. So it comes up this way, about 45 degrees.
Okay. And if we can get a point, if I can GPS a point, because I know under that big boulder, right?
Yep.
It comes right up there, so we'll GPS that in. That'll give us more data to georeference in that map.
Yeah, when we bring the surveyed model we have into the GPS, GIS stuff.
Yeah, when we bring that plan map that you've got, it's got the fault rays plotted, we'll have the van exposure, we'll have the blacksmith shop, and then we'll have that point.
Nice.
And we'll get a pretty good ref in there.
Nice. So this is a nice, very nice flat surface. We're calling this fault ? Is that what we're doing?
Yeah, we're putting a question mark. It's probably the fault. I mean, it's the fault.
So yeah.
So I'm gonna
but we're getting it.
Yeah, we're getting it.
Getting it.
We're gonna get a
in
bunch
here.
of data on the way up, and that way we can get a really good strike on this.
Yeah. What are you reading on that one?
81 to the west, 275.
So 270 would be north-south. Oh, no, wait.
I'm reading out dip direction.
Okay.
So it's dipping towards 275.
Yeah, okay, which is directly west.
Yeah, so it's
Yeah.
dipping real steep to the west.
And
Which
striking
makes sense,
north-south.
but yeah, we got that on the geomap too. It's just that that geomap's big scale.
Yeah.
It doesn't have any dip on it.
Yeah. You're not even seeing these on there, are you? These guys? I'll have to look.
I don't think so.
I don't think
get
they're
in
on
the
there.
shop there.
Yeah.
Default. And then we'll come over here and we'll grab these foliations on the way up
Okay.
and see how they change from what we've measured before.
And another thing that we did, years ago actually, when we were up here, is we were looking at this fault, but I'm going to turn around 180 degrees, and we were lining it up with that structure right there. And so we can say this fault continues across the valley below us, boom, right there, and we walked all the way down this ridge, and we were lining up these faults. Every time there's a little dip, there's a fault. There's a fault, there's a fault, there's a fault. And you can stand on that ridge and look back at this valley, and you can line up these faults coming all the way across. And so they're pretty major structures in the mining zone here.
Yeah, they are really big, and they're all really parallel to that intrusive contact.
Yeah.
It's just off to the east, just on the other side of that creek.
Yep.
Well, and obviously we have some of it near the portal too.
But yeah, no, it's all just stacked up like a deck of cards here.
Yeah.
So now you're on the west side, trying to get some foliation here.
It's kind of like this, huh?
Yeah. Can you get anything right behind you on the right? Oh yeah, right there. There you go.
So much moss out here, Jason.
I know. It's not like desert mining.
Yeah,
desert
get out here and
prospecting.
power watch it. Yeah, like that. That's close enough. So that's 59 towards the southwest. That's pretty parallel to vein orientation, right? Or it's a little steeper, but
yeah, a little steeper. What's the strike on it?
it's dipping towards the southwest, 149.
Okay. I think the vein was 105 and 52 or something.
Yeah.
So
Getting
we're
warmer.
getting there. We're getting warmer. Well, we're getting close to the vein.
Yeah.
The vein's right up there. And so that might be again that you're seeing the limbs of the hinge, the limbs of the fold
Yeah.
coming into vein orientation.
Yeah.
We're working our way up this fault. We're getting real close here. I'll show you on the west side. Really hard to see, but there's a little bit of vein right there. The vein runs right up that way and around those trees. It comes down into the fault. There's this massive rock laying here. And then on the other side of the fault, there are two different quartz veins here. Like we saw at the blacksmith shop, there's a lower one that runs up like that. And then above it, and the closer you get to the fault, they look like they're coming together. But above that one, as you get away from the fault, it's running right up there, and then it runs up and around the corner there. So that you have one here, you have one down here. So they're diverging as they get away from the fault. But it's super fascinating to me that on the east side of the fault, there's dual veins, and on the west side of the fault, it's a single vein system. We're under this big rock, checking out the veins. I want to show you right down over here. Right there in that big old puddle is where the fault raise comes up under this big rock. So when we go underground, the fault raise is going to be absolutely just a waterfall. Just tons and tons of water coming down it. But all this water's running right down this fault valley, and then it's flowing all right down the raise, fault raise. We're getting a little bit different numbers here next to the fault.
That one's pretty consistent with what we measured over there.
Okay.
54 towards 133.
Yeah, that's pretty close.
Yep.
That's pretty darn close.
And then this joint's just a little more west trending or east trending than our main fault. Our main fault's kind of coming through like this.
Okay. And so again, the veins come down like this. They're coming together. The closer to the fault you get, there's upper vein, lower vein. Go right over by Dale, right through the fault raise, and then come out underneath this talus, right up there, under those trees. It's very, very narrow on this side though. So it pinches on this side of the fault and is in one structure. And over here on this side of the fault, it's two structures and they're quite a bit wider. So we're looking, I was actually wrong when I was pointing out earlier. Here's a little bit of the vein. It runs right up there, right on that little knob right here. There's some vein. Then you can kind of see the structure runs right up there. So that's the vein on this side of the fault. Right up there, it's narrow. It's 6'8" inches. We're doing a little double check here. Can I help you out there?
Yeah.
You need a plane or something?
Yeah,
something like that. This is really winging it.
South 25 east.
We're just coming out of the fault. There's the fault kind of valley right up behind Dale. So we're coming around this face. We're going to grab some shots on the way down. There's a vein right out here that we're going to grab some shots on. There's a portal there we're going to grab a shot on. The stope holes are up here we're going to grab a shot on. And then we're going to go underground. Here's a surface vein that has not been mined. I took a shot on this a few years back. But we're getting some strikes and dips on it. It's definitely something that we should plot, but it's a little bit of an enigma because none of the reports talk about it. The miners didn't touch it 125 years ago. It's just sitting here. It's actually pretty interesting. It's got these big inclusions of wall rock in it, so it just came ripping through there. And in the mine, in the stope, where we see these inclusions of wall rock, we typically don't see any mineralization. All right, Dale, what are you seeing?
Oh, we're picking up a subtle fabric that's kind of merging with this vein. It's kind of coming in through like this. You can really see it. You see it kind of coming in. Some of these folds, some of these little quartz kind of sweat veins are kind of folded into it. Pretty subtle. There's one right there. But the one that's more clear is this foliation. You know, like your kind of, whatever that is, if it's chloride or whatever your phyllosilicates are there, they're really kind of platy and they're kind of running down, right down into that. Yep. That fault plane.
And what does that tell us?
That helps us understand the kinematics. So which way each block has moved. So in this situation where you're in like kind of in this like brittle ductile kind of transition, you're like kind of riding that boundary. It looks like this block here probably would be moving. This one would be kind of moving this way and dragging that foliation up like that.
Yep.
You agree with that?
Yeah, I think so for sure.
Yeah.
I think it looks like it's rolling right in, and I think we took some foliation stuff over there, and it was lined up like this, more or less. Then as you get close to this vein, it's starting to roll, boom, right into the fault. I mean, there's a real nice little movement plane right there.
Yep.
You got this vein right in the zone.
Yep.
So yeah, I agree with that 100%. How close does this vein strike and dip with the fault raise, or the fault over here?
It's dipping off to the east steep. The fault race fault is dipping off to the west steep.
Yeah, right. Okay.
So it's, you know, they're kind of sitting like that maybe.
Yep. But they're striking both pretty much nuts on north-south.
Nuts on north-south. And this thing's, from what we think, is pretty dead.
Yep.
Right? And you know, it could have been one of those last gasps of quartz that were kind of coming up through that extensional north trending fault that we've been working with here.
Right. And it's interesting that it's in a very different orientation than our vein that pays.
Yeah.
So that may be the stresses change, the orientation of the block change, and you got this last or first gasp of quartz out of the system, but it didn't carry any values with it.
Yeah, that on this side, I wonder if we can see the indicators that are kind of opposite.
Yeah, coming up. I looked a little bit. This side looks a little more raggedy.
It does. It does. It's coming in, and it's a little more of a hard break.
Yep.
Right there, not as much plastic. You got a little bit of a fold happening right in there.
Everything here, it just like comes right in and bam, gets cut. I don't know. You could almost argue it's coming down and getting rolled in, maybe, because this out here is more vertical. I don't know.
Yeah.
Arm waving stuff.
This side's less
obvious.
Less obvious.
Yeah, we're up here at our stow poles. This is our escape route here. We're gonna get a GPS coordinate. There's a couple, 2 or 3 stow poles here, and then we can get everything lined up in space and on our map.
Got it.
Nice.
This vein, eh?
Yeah.
Need a waterproof phone, YouTube.
Make it so we can scroll on our phones with wet fingers.
Yeah.
Got a nice hanging wall there, yeah.
Yeah.
Bam.
30 towards 128. Perfecto. Dang.
30 towards 128. Well, that's the same as we had over the blacksmith shop.
It is. We had towards 105, 115 over there.
Yeah.
Yeah, man. Well, that's interesting. Once you get away from the fault.
It's a little weird by the fault, but then once you get away from it, each side is the same so far.
You like that?
Yeah.
Take a shower.
Look at that, man. Yeah, it's been wet. We're up here measuring the westmost portal, and we're seeing for the first time again on the west side of the fault, you got vein here, you got waste in the middle, and then you got vein up high again. So the vein is split here again, just like it does on the east side. So we have the vein coming up here, just you got those portals, one there, you can't really see. It's dipping to the east and rolls right into that fault and starts dipping to the west. That's really cool. I don't know if you can get it on camera, but the vein comes up and just rolls right into that fault. And now we're on the east side, and the vein continues up the hill. We'll get some strikes and dips here. Here's where we're seeing our vein come out of this fault zone, but we're still getting the veins broken here by this little slip. Jogs up a couple feet, and then you see it continue up the hill here. So you're getting some stuff going on with the vein as you come out of this fault zone, but I think it's striking and dipping back to its original deal, right? I don't know, we haven't got a measurement over here yet, actually.
Looks like it.
Stay tuned. So we just took a strike and dip on that brown face right there, 41 towards 160. So it's back kind of where it needs to be.
Yep.
Where it should be. Getting away from that fault.
Starts to behave.
So our vein comes across our face here, down underneath, and all of a sudden, boom, it rolls right up. We're standing on it, right up behind Dale, and right almost, I mean, not vertical, but it goes way high.
Yeah, kind of through that gap in the trees.
Yeah, and up it goes. And it actually, maybe is it flattening off right up there? I don't know.
Hard to tell.
It's definitely changed directions. Our strike and dips will tell us. So now it's striking 71 towards 100.
It's dipping 71 towards 100, so it's dipping to the east, southeast. So it had rolled over to the south, dipping to the south.
Yeah.
Once we got to that fault.
Yep.
And now we're over here, and it's taking much more of it, dipping much more towards the east.
Running.
Even more so than you normally have.
Yeah.
Kind of in the guts of that fault block over there, where where your main vein is.
Well, if it's dipping to, what did you say, 100?
Yeah, it's dipping 71 towards 100.
So that's almost north-south trending, striking.
So that's kind of our extensional orientation, that big fault we're in.
Yeah. So it's rolled into a north-south trending zone. All right, we're over at another section of the property that has a vein that was mined in the past, and it's much more vertically dipping, striking much more north-south. Dale's going to take a strike and dip on it here and let us know what he gets.
83, the east.
Towards the east.
Yep.
We've gone maybe hundreds of feet, 500, 600, 800 feet, maybe more, away from the contact of the intrusive, and our rock is changing now a little bit. It's probably would still be considered a phyllite, but we're trying to find foliation in here. It's a lot harder, and there's almost no sweat quartz at all. We're not seeing hardly any of it, and we were just talking about maybe as you get farther away from the intrusive, maybe that big intrusive batholith did a little contact metamorphism on the phyllite, but then once you get away from it, you don't have any more sweat quartz, which is interesting.
Yeah, it's one of the most obvious changes in the rock. Just loss of all that quartz once we got west of.
And we've gone, I don't know, a couple hundreds of feet off the con.
Or so.
Yeah, and like you said, we've passed 2 or 3 different faults.
Yeah.
So you could have way different environment over here. All right, we are underground now. Moving our way in from the blacksmith shop. We've just intersected where the vein is here in the lower haulage way. We've got some stations going. I'll show you how I'm doing this if I can. So on our map here, we're referencing stations 1, 2, 3 as we go along. Dale's using his phone, taking all of his good data, and then we can put all this into Leapfrog when we get back to the office. We are going to take a ton of data in here, so I'm not going to film it all, but I just want to show you guys kind of how we're doing it. We got some foliation, we got a little fault here we measured, we got some jointing. Spiders!
Oh, spiders everywhere.
Dale, all the spiders are in here for the winter or something, and Dale's freaking out.
I'm not into spiders.
Not into spiders so much.
No, especially not dozens of them hanging out on my veins. Let's see. We're at station 3.
Yeah.
Vein. So Jason's got that plotted on the map. That's all we need.
And I'm taking notes in my book here. So I got station 1, 2, 3. It's real wet and drippy, and there are spiders everywhere. Spiders! Ow! Spiders there. There's spiders over here. There's spiders everywhere. Where's that big cluster of them? Oh, they're somewhere in here.
Dude, right there.
Where? Oh yeah, look at them all here. Oh, spiders.
So that's more spiders than anybody likes.
That's more. You don't need that many spiders. No one needs that many spiders. So this is where we like to spend a little bit of time, because coming in from the blacksmith shop, we've been following this vein right along here, the lower vein, if you will. And then you hit this place where the old miners came onto this upper vein right here. 3+ feet wide, huh? Nice looking vein. And one of the best rocks I've ever found in this mine came off the hanging wall right up here. Loaded with gold. Nice. Right up on the hanging wall on the upper vein. So I think this vein here carries the goodies, and the miners were checking that out because they went down and checked out back in there.
Now I feel like I'm mining 100 years ago, carrying my
Carry your lantern around.
That's what you get when you leave your cap lamp in Idaho.
Yeah, we're making do. Well, we're finding something really interesting with the foliation in here. The footwall foliation is oriented pretty much perpendicular to the drift, right where we're at. And then the hanging wall foliation is parallel with the drift. And so your hanging wall and footwall foliation are very different. So you must have had some movement along this vein, right?
Yeah, it's as good evidence as any. If you're on one side of the fault, it's going one way, and you're on the other side, and it's doing something completely different. That means this vein had probably a pretty significant amount of displacement.
Yeah.
In order to change the orientation of this rock.
Yeah. So what did you get here? Do you remember off the top of your head?
Yeah, it's north-south. It's dipping steep to the east.
Okay.
And over here, let's grab one real quick. It's pretty much this whole fabric that's like making it.
Yeah.
So that's dipping 38 towards 212, so the southwest.
Yeah. So they're almost perpendicular. So this is back in the old powder room, actually. And they blasted some stuff, some old dynamite off back in the 60s, I think. And it cleaned up the wall real nice, so we can get some really, really good foliation in here.
The foliation's been helping us really kind of understand what we've moved into these different fault blocks, and it's like becoming kind of a reference in space relative to the way the veins are dipping. So that's why we're trying to find it. We're kind of way out in the footwall.
Yeah, in the footwall, yep.
So we're trying to sort out if this foliation is consistent away from all the faulting. That's something that we've noticed outside, noticed in the drift a little bit over here, and
You can tell where you are in relation to the vein.
Yeah.
Up in the footwall or hanging wall, depending on what the foliation's doing.
Right, and when we were looking at that vein earlier, and we were kind of in between the upper and the lower, the foliation was just out of control.
Yeah, it's totally different.
And so if you're in an area where the foliation is just, it doesn't make any sense. You're either next to a structure or maybe next to a vein.
Yeah. All right, we're back here right at our face where we left off, and we were measuring these slips that have been giving us trouble all season. These gougy slips that were making water. They were cutting off our explosives and all kinds of stuff, and they line up pretty darn well with the fault orientation. They're a little bit off. That's probably why we're intersecting them, but I think we're getting real close to the fault.
Yeah, they're only like maybe 30 degrees off, which is, normal for a big fault zone.
Yeah.
So
you're getting these little strands of the fault kind of weaving around.
And then the foliation is really just folding all crazy in here. It's not our last normal foliation, which is generally trending north-south. It's like 8 feet that way.
Okay.
And now over here, it's just rolling all over and being all crazy, which we saw outside when we were next to the major faults.
Yep.
The major north trending faults.
Yep.
Seeing it right here, making water. Yeah, man, so you're close.
We're getting real close.
You're getting real close.
Yep. And we're going to come in at like a 45-degree angle to it. And so we got 14 feet or so more to drift till we think we hit the fault raise. And I think it's just going to keep getting worse and worse for us. You're going to have these little slips, these little water problems. You're going to have, we just blasted on this, but it's all screwed up. It just makes it real hard when it's all kind of gouged up and
drifting through a fault zone's not easy.
No bueno.
No bueno. But man, once you get there,
it'll be frickin' Christmas time. Yeah, it'll be great.
That's not too bad. So is that going to be 2 rounds for you or 3?
Probably 3.
Yeah.
We'll do 4.5, 5 foot rounds, and 3 of them will get us there.
Who wants to buy some waste?
Yeah. I got lots. I got lots.
He's gonna have a few tons of waste for everybody.
Yeah. Everybody gets a bonus 500 pounds when they buy 1 bag of ore.
Yeah. Yeah.
Cool. Well, I think kind of our next step now is to get all this data on a computer, huh?
Yeah, man. We got that process started over lunch. We got the blacksmith shop roughed in.
Mm-hmm.
Then we got to get the fault raises in there and all the other raises. And get this in there so we can see how close our model is compared to where Jason thinks he's at. I'm gonna bet Jason's probably closer.
I hope I'm pretty close.
I think you're probably pretty close.
I'm kind of flying blind a little bit, but I mean, judging by the geologic signals we're getting, we're getting close to something.
And that's one of the big benefits of today.
Oh yeah,
as we were running around looking in a little more detail than normal at what the rocks are doing next to the faults, what the veins are doing next to the faults. We got a lot of really good data now underground that we can plot up.
Mm-hmm.
And it's all that kind of information that as you're kind of flailing around out here, helps you understand if you're close to your target. We see a bunch of our joint faces or our fault slips that are near parallel to our main north trending fault set. So you're getting there.
We're getting there. And that's the other thing is we're not going to answer all the questions today.
No.
We're not gonna answer all the questions. We're gonna go and put all this stuff in a computer, and we're gonna have 10 more questions than the 2 we answer probably.
That's how it goes, man.
So
that's how it goes.
Yeah.
Yeah.
But you're just building a library at this point. You're just getting data and add more data next year, and we'll get this thing figured out.
Yeah, we've been running up here for years and years, and now we're finally actually getting. 3 years ago, was it? We plotted the drift.
Yeah, 3 or 4. Yeah.
3 or 4 years ago, we plotted the drift. All the other times we were running outside, we just kind of arm waving. Now we're getting that data in GIS and then in Leapfrog. So, making some progress.
Yeah.
Taking a little while, but it's I think it's going to be pretty cool to see when it's all done.
I'm excited to see it in the 3D model.
Yeah, me too.
All right. Well, let's take a few more measurements or whatever we got to do, and we'll get out of here.
Okay. Sounds good.